Hi everyone, welcome to Chemistry Classroom. In the last tutorial, I have shown you how to prepare 0.1 molar H2SO4 solution using this particular equation. If you have not watched that particular video, I have given the link of that video in my description, or you can see it on the I button where you can go and watch the tutorial as well. But that was too simple, so my last video was all about preparation of 0.1 molar H2SO4 solution. We simply put in all the values right over here and determined the volume of H2SO4 that needs to be taken out of the bottle, which is then placed into a volumetric flask. For example, it was 5.8 ml, and then distilled water has to be added to the volumetric flask to prepare 0.1 molar H2SO4 solution. So in this video, I'm going to show you where from we have got this equation, because normally you won't find this particular equation in chemical literature. Now let me show you how we can derive this particular equation. Now molarity can be defined as a number of moles of solute dissolved in 1 liter of a solvent. Number of moles of solute divided by volume of solution in dm cube or liter. Let's say it's our first equation. Now you know that a number of moles of solute can also be written like this. Number of moles is equal to mass of solute divided by molecular weight of the solute. Now both these terms should be in gram. So this is our second equation, and now we can actually plug in this equation into our first equation right over here in place of number of moles of solute. So let me put in number of moles of solute over here as well. So this new equation would become is, let me write molarity as M is equal number of moles of solute. So let's put in number of mass of solute divided by molecular weight of solute. And similarly, we can write 1 over this volume of solution in liters. Molecular weight of solutes and volume of solution as per arithmetic rules. So we can write actually like this: molarity into molecular weight of solute into volume of solution in liters, and this becomes equal to mass of solute in grams. Now if you are to prepare a molar solution of a solid solute, then you can simply use this particular equation to determine the mass of the solute that needs to be put into a volumetric flask. Simply put in the distilled water, shake it, and you are done with your solution. For example, if we want to prepare 0.1 molar sodium hydroxide solution, then what we will do, we'll write simply over here 0.1 molecular weight of sodium hydroxide is 40, and volume of solution within which we are preparing this solution is 1 liter. So simply multiplying all these terms, we would get 4 gram. Now you can simply take a volumetric flask of 1 liter and put in these 4 grams over here, and then simply add distilled water into this particular flask. Let's say it is 1 liter flask. First put in a few ml of the distilled water, shake it. When it's completely dissolved, then simply fill it up to the level where it says it is equal to 1 liter. Then boom, you are done with your solution. Now if you have to prepare 0.1 molar H2SO4 solution, then the job become quite tedious. As you can see, it is not the mass that needs to be calculated, rather it is the volume of the solution that needs to be taken out of the H2SO4 original bottle, and then a molar solution is to be prepared. And one more thing, H2SO4 or HCl is not 100% pure. So we need to make sure that the percentage purity of the acid is also being taken into account. So let me show you how we would do that. You know, mass of the solute can also be written as volume into density. So in place of mass of solute, we can also write like this: density into volume, and make sure that this volume is in ml. Now this is actually the density of that particular solute whose solution is going to be made. So in our case, we are going to prepare 0.1 molar H2SO4 solution. Now we can simply take density to the other side of the equation, and we would be left with volume. But the second problem was the percentage purity that must also be taken into consideration. So for that, I'm going to write percentage purity over here is percentage purity is equal to, let me write all these terms again. So you can see molarity into molecular weight into volume of solution. So we are only concerned with volume over here. So we can actually divide this particular equation by percentage purity and density, and this new equation would look like this. We can write volume in ml is equal to, let's write molarity, molecular weight, into volume of solution in liter or dm cube, and divide it by density, it's density of the solute, into percentage purity of the solute. Now in case of H2SO4 is normally 96%. You must check the bottle in your lab to make sure that it is 96%. It might be 80% or 86% as well. So whatever percentage is written on the label, put it right over here into this equation. And density of H2SO4 is 1.83 gram per centimeter cube. You must also check this particular value on the label of the bottle as well. Now let's put in all these values into this equation to calculate the volume that needs to be taken out for the preparation of 0.1 molar solution. I have already done this in our last video, but let me do it quickly over here as well. Volume in ml is equal to molarity that we are going to prepare is 0.1 into molecular weight of H2SO4 is 98 gram per mole. Volume of the solution that we are preparing our solution is, let's say it's 1 liter. If it is in 500 ml, then you must write 500 ml divided by 1000 to convert it into liters, divided by density 1.83, percentage purity in this particular case is 96%. So you would write 96%, which means 96 divided by 100. So this 100 would go up into the denominator. So again, we would write 0.1, 1.83 into 96. Now simply multiply these terms in the numerator and in the denominator, then divide it. Then you would get the volume of H2SO4 that needs to be taken out of the bottle and placed into volumetric flask to prepare 0.1 molar solution. Let me do these calculations quickly. Now this is the original H2SO4 solution that needs to be put into 1000 ml flask, and then distilled water has to be added till the mark given on the flask, and your 0.1 molar H2SO4 solution is ready. So this particular video was concerned how this particular equation is derived from simple equations to calculate molarity of a liquid solute. I hope you have found this tutorial useful. Please give it a thumbs up, subscribe to my channel, and thanks for watching.